This is the class on Taste of Sutras. We are going to talk about sutras as they are used in Vedic Math. And I use this material as the first class to give an introduction to different topics as a background. I'm Sarwan Agrawal and I'm a certified teacher. Let's do some very brief historical background here. Veda means knowledge, and Vedic system of mathematics, which is knowledge about mathematics, was constructed between 1911 and 1918. Bharati Krishna wrote one introductory volume in 1958, and the book Vedic Mathematics was published in 1965. And here is one of his pictures. We talked about sutras, at least the title says sutras, and let's see what sutra is. What's a sutra? It's a word formula or a phrase which guides the mind to solve math problems. And editors of Tirthaji's book compiled a list of 16 sutras and 13 sub-sutras from stray references in the text. For our purpose, any word formula or a phrase which helps solve math problem is a sutra. This is a guide to the mind. We're going to talk about completion. Here use sutra by completion. To show its use, we are going to use this as an example of 23 minus 18. Observe that 18 is close to 20 and 2 below it. So we're trying to make 20 here out of instead of 18. But we just can't change 18 to 20. That would change the problem situation here. We do have to maintain integrity of the problem. So what we do is we add and subtract 2. Then we regroup them. The plus 2 we combine with plus 23 and minus 2 we combine with minus 18 here. Now the equivalent problem is 23 minus 28 is equivalent to 25 minus 20. It's 25 minus 20, and 25 minus 20 is a 5, which is a lot easier to solve than 23 minus 8. So what we did is by adding and subtracting 2, we replaced the problem 23 minus 18 by an equivalent problem of 25 minus 20. We completed 20 and used by addition and by subtraction. Our intent was by completion. Our means to accomplish that was by addition and. Now we're going to show you another example here. Let's try 53 plus 49. Note that 49 is close to 50. You would note that 53 is also close to 50. 50 plus 3 more than it. This is 1 less than. Okay. So 49 is close to 50 and it is 50 minus 1. So we just can't add 1 to 49 without also subtracting 1. So we do 53 plus 49 plus 1 minus 1. This is by addition and subtraction. Now we regroup them, so we're trying to make 50 here from 49 plus 1. So minus 1 gets combined with plus 53. Problem become 52 plus 50, which is 102, which is not easier to solve than 53 plus 40. Okay, we're going to do another example here. This time it's problem of multiplication, and we are multiplying 75 times 25. Observe that 75 is close to 100 and is 25 below it. So how do we achieve 100 minus 25 from 75? By adding and subtracting. But first add 25 to 75 become 100, but we also have to subtract 25. So equivalent problem becomes 100 minus 25 times 25. And now we can multiply them. 100 times 25, that's this section here. and minus 25 times 25 is that part of the problem is. Multiplication here is straightforward. Multiply by 100, add 2 zeros to the right, and minus 25 times 25, it is minus 625. We do have a section in finding square of numbers ending in 5. In that section, we use a by one more than one before. 6 here comes in by multiplying 2 by 3, which is 3 is one more than before. And 25 here comes from 5 times 5. So you can do another way you think of, but in Vedic Math, we do have a Sutra by one more than one before to compute 25 times 25 equals 625. And which is a we're going to do the same thing again. This time we are going to use by multiplication and by division. Problem again is 75 times 25. Observe that 25 is equal to 100 divided by 4, which means we have to achieve 100 divided by 4. We multiply by 4. We multiply 25 by 4 to get 100. And for the integrity of the equation problem, we divide by 4. So we have problem is 75 times 25 times 4. This is by multiplication and division. And that's 75 times 100. 25 times 4 is 100. Okay, and that is 7500 divided by 4, because multiplication by 100 adds 2 zeros to the right, which is 1875. If you're uncomfortable dividing by 4 in one step, you can do it in 2 steps, half at. Okay, let's go make observations what happened in this thing. We solve this problem in 2 different ways. First, we replace 75 by 100 minus 25 using by addition and subtraction of 25. Second time, we replace 25 by 100 divided by 4, which is when we use that using by multiplication and division. First, we multiply 25 by 4, then divide by 4. Question is, we solve 2 different ways. Can you solve in more different ways? There are a lot, I can think of a few more. So let's see how many ways you can think of. Okay, now we're going to do example 3 of by addition and subtraction. And we're going to use a example from algebra this time. Let's see what we can do. Factor a squared minus b squared. Okay, how you do that? We're going to use by addition and by subtraction, and the expression a squared minus b squared become a squared plus ab minus b squared. So we just added and subtracted a times b. Now why do we add and subtract a times b? First, note that a squared must come from a times a, and b squared must come from b times b. Any factors involving a and b, when you multiply them together, must have some term involving a, b. Okay, and that's where we got a, b plus a, b and minus a, b. Okay, and then when you regroup them, a squared plus ab has a factor of a. Factor out a from here become a times a plus b. Minus ab minus b squared has a factor of minus b. So it's minus b times a plus b. Now when we have a common factor a plus b, so we are going to combine that and extract out the factor a plus b. Okay, that become a plus b times a minus b. So we just factored a squared minus b squared and into a plus b times a minus b, and we use that addition and subtraction of ab to do. Now we're going to study components of 10, and let's see what they are. 10 is 1 plus 9, is also equal to 2 plus 8, is also 3 plus 7, is 4 plus 6, 5 plus 5, and 1 plus 2 plus 3 plus 4, and like this. You can find out other components that makes up 10. We would try to find these components to simplify our addition problems. Now we're going to look at example. Okay, here's a problem. For example, 234 plus 471 plus 586. So that find out components of 10 in this thing, and use that to simplify the problem. Okay. So here's the problem we have: 234, 471, and 486. I have bolded out 4 and 6. 4 plus 6 makes 10. We're going to use that to add in the units column. So 4 plus 6 is 10, plus 1 is 11. So in units column we have 4 plus 6 equal 10, and but there's the 1 also here. So 4 plus 6 plus 10 is 10, plus 1 is 11. Okay, for 11 is 10 plus 1. We use the last one here as in the answer in the units column, and this 10 becomes 1 in the as a carry in the tens column. Now we're going to continue this example here. So this is the problem from last time. Okay, and this is the what we had: 1 and a carry. We had this 1 here and carry 1 for the column on the left, let's say tens column. So this time I have highlighted 3 and 7 because 3 and 7 are components of 10. So in tens column, so is 3 plus 7 is 10. Okay, and the whole thing is 3 plus 7 plus 8 plus 1 from the carry, which is 3 plus 7 is 10, 8 plus 1 is 9, 10 plus 1, 9 is 19. So which is, we are going to use 9 in the tens column and get a carry for the hundreds column. And now we would continue with this example here. Here's the problem from previous page. Here are the two. We had 11 on the units place with 1 carry, 19 in tens place with 1 carry. Okay, and I have highlighted here again 5 and 5. 5 and 5 is highlighted because they make a 10. So 5 plus 5 is 10. Then 5 plus 5 plus 2 plus 1 from carry is 13. So 10 plus 3 is 13. There's no other place to carry on the left. So 13 is the answer in the hundreds and thousands column. Let's see what we do here. Okay. So we have answer so far is 13 and 91. So answer is 1391. So 234 plus 571 plus 586, 234 plus 571 plus 586 is 1391. Okay, we're going to use a mental addition this time. Mantra in Vedic math is short and sweet, one line mental solution when possible. Did you see a fine print? When possible is the fine print here. Otherwise, simplify as much as possible and no more. Okay, let's see what example we use here to show mental. All right, we're going to do example for mental addition here. Example is 267 plus 543 plus 634, and we are going to add these three numbers mentally. So let's see what's going on. In hundreds place we have a 2, 5 and 6. That's 200, 500 and 600. So we have 200 plus 500 plus 600. 200 plus 500 is 700. 700 plus 600 is 1300. So 1300 is the sum of the digits in the hundreds place. Uh, sum of the position hundreds place positions here. So we are going to remember 1300. So remember 1300, which is a one number to remember and not that bad. So we had a in previous column we remember 1300. In tens column we have 6 plus 4 plus 30. That's 60, 40 and 30. 60 plus 40 plus 30 is 130. Add 130 to 1300, so become 1430. So sum of the digits in hundreds columns are values of position. This position is 100 column and tens column is 1430. So remember this number 1430. Now in this we continue. We had already remembered 1430 from adding to 260 plus 540 plus 630. Now I have to add the digits in the units column. Units place we have a 7 plus 3, which is 10, plus 8, 18. So we are going to add 18 to 1430. So we come at 14, 848. So 1430 plus 18 is 1448. Answer is 1448. That means 267 plus 543 plus 638 is 14. Now we are continuing with the by completion here. Problem is 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. We're going to complete tens here. 1 plus 9 is a 10. 8 plus 2 is a 10. 3 plus 7 is a 10. 4 plus 6 is a 10. And then the 5. So we get 1 plus 9 plus 2 plus 8 plus 3 plus 7 plus 4 plus 6 plus 5. So which is 10 plus 10 plus 10 plus 5. Okay, which is 45. We just added 1 through 9 and it became a 45. And we were completing tens. We just computed sum of arithmetic series by using by completion. But we were trying to complete a tens here because first term and last term added up to 10. Now let's try another example here. Now instead of adding first 9 digits, we are adding first 10 numbers here. We can add a 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 and plus 10. Here we are going to complete 11s here. 1 plus 10 is 11, 2 plus 9 is 11, 3 plus 8 and so on. So we got 11 plus 11 plus 11 plus 6, which is 55. And if you're uncomfortable adding 11s, you can add 10s 5 times and then add 1s again and 1 5 times. So we get 10 plus 1, 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 which is 10 times 5, 50, 1 times 5, 5, 50 plus 5 is 55. Okay. We just computed some of another series using by completion. And if you really wish to add just 10, just add 11s, you could add 0 to the left. You can add 0 to the series. We have 0 plus 10 plus 1 plus 9 extra, which gets you into 10 plus 10 plus 10 plus 10 plus 10 and 5. Okay? So 55. Now we're going to do another example using completion. And example here is 1 plus 3 plus 5 plus 7 plus 9. Note that these are not the consecutive numbers, but difference between two consecutive terms is 2 instead of 1. And this is a sum of odd numbers. 1 is odd, 3 is odd, 5 is odd, 7 is odd, and so is 9. And we are adding first 5 odd numbers starting from 1. Okay. Here we are going to complete 10. 1 plus 9 is 10. Okay. So when you complete 10, we have 1 plus 9 from here, 3 plus 7 and 5. So which is 10 plus 10 plus 5 is 25, and it's equal to 5 times 5. Number of terms being added are 5, and result is 5 squared. Okay, now we're going to look at another example over here from we are trying to add odd number from starting from 1 up to 15, and number of terms is 8. If you observe here, if that holds, we should get 8 squared as the answer. Let's see what we got. So here we're going to try to complete 16. 1 plus 15, 3 plus 13. So 1 plus 15 plus 3 plus 13 plus 5 plus 11 plus 7 times plus 9, which 16 added 4 times, which is equal to 64, and it is 8 times 8, just like we predicted before. It was number of odd terms added starting from 1 was 8, and its sum is 8 squared. So what we did is, observation here is adding odd numbers starting from results in a square of numbers of added terms. Okay, all right. Now let's see some exercises you can try for yourself. Okay, you can try 63 plus 27, 66 minus 38, 87 plus 93, 96 minus 78, 234 plus 674 plus 853, and then sum of terms, sum of numbers from 1 through 99. Now we're going to discuss another sutra by last digits. Okay, and for that we're going to try this number, add this number 478 plus 157 plus 326 plus 473. So we are going to add 4 numbers of 3 digits each. Okay, here we are going to add, note the carry. So right away, as soon as we get a carry, we note that and continue only with the last digits. So mental addition is going on with the last digit only. And we will continue the process on the next slide. Okay, we continue here. Same problem again. So we are going to add in the units place. 8 plus 15. We already have 2 digits. That's 15 is 10 plus 5. 5 we're going to carry with, and 10, which becomes a 1 as a carry to the left, we would make a note of. So we have 2 digits now, 15, which is 10 plus 5, and 10 becomes carry for next 10 columns, and we continue with the 5, the last digit. Okay, so we come back here. We just note to carry here, and 8 plus 7 is 15, and we go and carry further with the continue our sum. We know 5 here, 5 plus 6 is 11. Well, again, we have a carry. Okay, we note that we just noted this thing and continue with 5. We did, and then we add 6 to get 11. Again, we note the carry and continue with the last digit, which is 1. All right, we continue the. Okay, here's the problem we had. We had noted down a carry and continue with last digit of 1. So at this place, we just note this carry here, we're just noting, and we continue with the last digit, which is 1. Okay, then 1 plus 3 is 4. So we have added all the columns. We have added all these columns here in the units place. We note that carry is 2, carry 2 for the tens column, and answer in the units place is 4. Okay, the same problem again. So we have 4 and the answer for units column, and 2 is the carry. So we are going to carry, continue this addition in the tens place now. So carry 2, 2 from carry, and 7 plus 5, 2 plus 7 is 9. Okay, so 9 plus 2, 9 plus 5 is 14. So we got 14 here. So we got 2 digits. So we're going to carry, note down our carry and continue the addition with the 4. So we were here and we noted this carry here and continue with 4. 4 plus 2 is a 6 and plus 7 is a 13. So we got a carry, 2 digits here. We're going to continue with 3. We know the carry and use 3 as answer in it. We have finished this column here of tens. So 3 is the answer and 1 is another carry we just discovered. So we were adding this 7 here and had a 13 with 3 here. With 1 we carried. Now we know that carry from tens place to the for the hundredths place is 2. We have a tens place, we have a 3 as shown above. And for the total of carry, okay, we are in tens column. We just had a 3 as answer, 2 carry for the hundredths place. We start in a addition in hundredths place. 2 plus 4 is 6. 6 plus 1 is 7. 7 plus 3 is a 10. We got to carry down. So we got 2 plus 4 plus 1 plus 3 is 10. We have 2 digits. We note 0. We continue with and note the carry of 1. Okay. Okay. So we are here. We had just come up with 10 and we continue with a 0 and we noted this carry here of 1. 0 plus 4 is a 4. So and we have 4 as an answer in hundredths place and there's a carry also for 1. So we have 14 here on the hundredths place. So we continue addition of the previous last digit of 0. 0 plus 4 is 4. We have hundredths place, we have 4 and a carry of 1 for the next column and there's no. Okay. So that's our answer here and the answer is 1434. We have answer of add 478 to 157 to 326 plus 473 and we get a 1434. Okay, we are going to discuss left to right. And here's the look at 1, 2, 3. How do we read it? 1, 2, 3, 123. How do you write it from left to right? We read, pronounce, and write numbers from left to right. The most important or significant figures are at the left. In Vedic math system, we can add, subtract, multiply, and divide from left to right. We have already seen how do we add from left to right. Okay. Mental calculations are easier from left to right. We can get the most significant figures in a calculation first and not the last. So we know when you do left to right, we get the most significant figures in the first. Let's try example here. 356 plus 263 plus 714. In hundredths place we have 3 plus 7 plus 2, that's 12. Keep 1 and carry 2 to the right. This 2 from hundredths place become 20 in tens place. Let's try that again. So what do we happen? We had a 1. We have 1 and a 2 carry for the tens place. In tens column we have 5 plus 6 plus 1. And that's and plus 20. Which is 32. We keep 3 and carry 2 for the units place. And in the units place, this 2 becomes 20 again. So we note it on 3 and carry for the units place. Units place, we have a 6 plus 4 plus 3, 6. So we added 6 plus 4 because I know 10. 6 plus 4 is 10. So we added first 4 plus first and 3 after. So 6 plus 4 plus 3 is 10 plus 3, 13 plus 20, 33. Answer is 133. Observation, we can take the carriage to the right as easily as we can take these to the left. Okay. Now we're going to try to use the system here, first term by first term and last term by last term. And here's the problem we're going to do to apply this first term by first term. So let's say x plus 1 is a factor that's a given of 2x squared plus 6x plus 4. Determine the other factor. So let's go see what's going on here. First, this is a quadratic expression, and this is a linear factor. Another factor must be linear too. The other factor must be linear too. Okay, so right here. All right. So linear factor is of the form a times x plus b. Of x is a variable, and linear factor must be ax plus b of time. Now we would use we have to determine what a is and what b is. To determine a value of a, which would satisfy a factor of 2x squared plus cx plus 4, we try first term by first term. A is a first coefficient, and 1 is a first coefficient of this. X squared must come from x multiplied by a x term in the other factor. So a times 1 must be 1 because must be 2 because 2 is the coefficient of x squared term. So a times 1 is 2. A must be 2. All right, we will use a. So when we come back on the next page, we already noted down this 2 for a. Now we have to determine what value of b is. B is the last term here. Last term by last term. Coefficient of b times 1, the coefficient of the constant term here must be equal to the constant term in the expression, given expression. So b times 1 must be 4. So b times 1 is 4, then b must be 4. Okay, so we are here, we have a 2x times 4. Now 2 is a factor of 2x plus 4. We take that out as a factor, another factor, so become 2 times x plus 1 times x plus 2. The other factor was 2x plus 4. But after we found that other factor, we can simplify further and extract out a common factor of from 2x plus 4 of 2. So the other factor was 2x plus 4, and the factors of 2x squared plus 6x plus 4 are 2 times 2 is a one factor, x plus 1 was the given factor, x plus 2 is what we just computed. Okay, we could have factored the same equation out using a by completion. First of all, we know x plus 1 is a factor. Okay, so now we can complete terms of factors of x plus 1. So we get 2x squared, and we know x plus 1 is a factor, so we'll just add 2x here, 2 times, but then it's split 6x into 2x plus 4x, okay, and plus 4, and we take out x plus 1 as a factor from first two terms, and similarly x plus 1 is a factor from next two terms. Then we extract out a common factor x plus 1 from here and x plus 1 from here. X plus 1 times 2x plus 4. So what we got? Again, there's a constant factor here in the second factor we just computed, 2 times x plus 1 times x plus 2. So we found the other factor of 2x squared plus 6x plus 4 two different ways. Once by using first term by first term and last term by last term, then again by completing x plus 1s. Okay, now that's the end of this class. In the real class settings, we would probably have lots of interaction, and back and forth would take longer than what we just did. And then I probably do different examples, maybe skip over some of the uh, examples we just did, use different examples, and maybe emphasize one topic or the other. But if you want to explore further, I used some material from Vedic this teacher's manual, Vedic Math Teacher Manual 1 by Kenneth R. Williams, and you can download that from this link here. And Vedic Mathematics by Bharati Krishna Tirthaji is the reference on the topic. Vedic Math for School you can look up. There comes in 3 volumes by James T. Glover. Mr. Glover uses these books in his school. Vedic Math for all ages is easy to follow, and author uses blue color to help the reader follow the steps. That's it for the today.